Hello guys, so today we are going to look at another set of problems which can simply be solved by iterating twice over the input array. Once from the front side, another from the backward side. Let's take an example. Given an array and we have to find the product of all elements except the number at index for which we are calculating the result. Suppose the given input is 1, 2, 3 and 4. And for this, the output array would look like, for 1 it will be product of 2, 3 and 4. It will be 24. For 2 it will be 1, 3 and 4, it will be 12. For 3 it will be 1, 2 and 4, that is 8. And lastly for 4 it will be 1, 2 and 3, which is 6. So this will be my output array. So for every index I, we need to calculate the product of 0 to I minus 1 to I plus 1 to n minus 1. And both the index are inclusive. It's just we are skipping the ith value. One way to solve this problem is simply calculate the product of all the elements by iterating over the array, and in the next iteration just create another result array and divide the total product by individual numbers. So that will give you the one answer. But here the constraint is we cannot use a divide operator, and also we have to do this in order of n. So to solve this, we need the product of all the elements left for index and also all the elements right to it. So calling this as LP left product and this as RP right product. So LP we have to calculate for all the elements. LP is an array of same size as the input array. So LP for 0th index will be 1 because there are no elements on the left of it. Then we'll iterate over the entire array from I equal to 0 to n minus 1, and LP of I plus 1 will be product of LP of I into input array I. This way we'll be able to populate the LP array. Similarly, let's take for the right, RP of n minus 1 will be 1 because there are no elements right to it, and we'll iterate from for I equal to n minus 1 till 0, and RP of I minus 1 equal to RP of I into input of I. This way we'll be able to populate both the left product and the right product. Now the next step is we have to calculate the final product. So we'll be simply iterating from I from 0 to n minus 1. Let's take another array result, call it R. R of I equal to LP of I into RP of I, and that's it. Now let's take a dry run for this. Suppose the given input is 1, 2, 3 and 4. Index is 1, 2, 3. Let's calculate the LP array. LP for first value it is 1. Then for index 0 it will be product of current element which is 1 and the previous one, 1 into 1 which is 1. For index 1 it will be 2 into previous value which is 1, so it will be 2. Then for index 2 it will be 3 into previous value which is 6. Now let's calculate the RP. Let's try to fill it from the back. Again 1, and then product of 4 into 1 which is 4. Now product of 3 into 4 which is 12. Lastly product of 12 into 2 which is 24. Now finally the result array would be just product of these two arrays, which is the 24, 12 into 1 which is 12, 4 into 2 will be 8, 6 into 1 which will be 6. So this is my final answer. Now let's try to code it on LeetCode. So let's code it on LeetCode. So let's get the length of the array, which is nums dot length, and we'll take two arrays LP and RP of same size as n. So int array LP equal to new int array of size n, and this is same thing we'll be doing for RP as well. And let's populate LP, which is for int I equal to 0, I less than n minus 1, I plus plus, and LP of I plus 1 equal to nums of I into LP of I. And also before this, LP of I, or say 0, should be 1. This way we are able to populate LP, and same thing we have to do for RP. RP of n minus 1, I will start from n minus 1, it will go till it is greater than 0, and it will be reverse, so it will be minus minus, and yeah, everything else looks right. RP of I minus 1, and will be RP of I. That's it. And finally we have to calculate the result. Let's take another array of same size, result array, which is result. So for the result array, the result will be I0 to till the last element, result of I equal to LP of I and RP of I, product of LP of I and RP of I. That's it. And finally return the result. Let's try to run it. Yeah, it is working for the input. Let me try to submit it. Yep, it's working with a runtime of 3 milliseconds, and it's faster than 43.21. So here we are taking three arrays to store the intermediate results, and so basically 3 times n is my space complexity, though constants can be ignored. So the overall space complexity is order of n, but can we optimize it further to reduce more space? So yes, we can do that. We can calculate LP, left product, while iterating along the array in forward direction. So we don't need this. We can reutilize the RP for result as well. So let's get rid of RP as well and use result instead. So result instead of RP. That's it on this side. So while iterating on this, let's take the left product as initially as 1, and then basically result of I would be result of I into left, and we have to update. Now the only thing is we have to update the left equal to the last left into number I. That's it, and everything else will remain same. Let's try to run it. Yeah, it is working for the test case. Let me submit it. Okay, now it's better. It looks better because now we are reutilizing the same space. The space complexity is overall order of n, and the code looks shorter and much more cleaner. So let's look at the next problem. Now let's look at another popular problem called trapping rainwater. In this problem, given n non-negative integer representing an elevation map where the width of each bar is 1, compute how much water it is able to trap after raining. So we are given non-negative integers in an elevation map, and each bar has a width of 1, and we have to compute how much water they will be able to hold after raining. So suppose for the given input, so if you try to look at how much water they will be able to hold, so here's one region, this will be able to hold 1 unit of water. Here it will be able to hold here overall 1, 2, 3 and 4 unit of water, and again here it will be able to hold 1 unit of water. So total 6 unit of water it will be able to hold. Now let's look at the logic how the value for this is derived. What's the maximum left to it, which is 2, and what's the maximum right to it, which is 3. What's the minimum of it, which is 2, and what's the height of the current value, 0. So it will be able to hold 2. Let's try to calculate for this. Minimum of, here the maximum on the left is 2, maximum on the right is 3, so minimum of them is 2, and then what's the value of it, value is 1, so it will be able to hold 1 unit of water. Similarly for all the others. So what we have to do here is, at any point we have to find what's the max on left and right for that element. So let's try to use the same analogy that we have followed previously. Iterate from left, calculate all the left maximum, iterate from right, calculate all the right maximums for an element, and then use those to calculate how much water will be trapped. Let's try to directly code it on LeetCode. So to solve this, we'll take two arrays, one to store the left maximum, another to store the right maximums. So let's determine the height first, and the n equal to height dot length, and the left, and the array left maximum equal to new int array of size n, another right maximum with height of, with length of same as n. Now I'll iterate from left to right and fill the values for in the left maximum array. So for left maximum, 0th will be, it will be same as height of 0, because that's the only maximum. And for int I equal to 1, I less than n, I plus plus, then lm of I equal to math dot max of lm of what's the maximum height that we have got till now, and that is lm I minus 1 and the height of I. So this way we will be able to populate the left maximum array. Similarly, we'll populate the right maximum. For right maximum, it will be n minus 1, height of n minus 1. We'll iterate from back, iterate from n minus 2 till it is 0, and similarly reverse loop. And rm of I equal to rm of I plus 1 and height of I. This way we have populated the right maximum, and finally we have to calculate the result, and the result equal to 0. And for and d I equal to 0, I less than n I plus plus, and result plus equal to math dot min of whatever the minimum height of left of I, left left maximum I, and right maximum I, whatever we have got with this minus height of I will give me the result, and finally return the result. Let's try to run it. Here we are going index out of bounds, so n minus 2 to, yeah, because we have already calculated for n minus 1, so it works for the input test. Let's try to submit it. Yes, it's got accepted. Here also you can do one modification. Instead of taking two arrays, we can take one array and another we can calculate while calculating the result, so that will in some way reduce the overall space that we are using. So let's look at another problem. So this is the last problem in this series, and this problem is also pretty much similar to the previous problem that we have solved. So let's read it. There are n children standing in a line. Each children is assigned a rating value given in the integer array ratings. You are given candies to these children subject to the following requirement. Each child must have at least one candy. Children with higher rating get more candies than their neighbors. And we have to find the minimum number of candies we have to distribute. We'll again take two arrays, one to store all the results from left to right, another from right to left. In both the arrays, we'll store the candies we'll be providing to these children in the way of their increasing ratings from left to right, and other way from right to left. We can copy paste the previous code, or for all the elements we'll populate with 0 arrays dot fill L with not 0 1. At least we have to provide one candidate to every children, so that's the least one. If the ratings are in increasing order, then we have to increment the candidates. So if the ratings of I is greater than the ratings of I minus 1, then we have to increase whatever the number we have provided from the previous one plus 1. Similarly here it will be if the ratings of I is greater than the ratings of I plus 1, then Rm of I equal to Rm of I plus 1 plus 1. Finally the result will be maximum of these two, and we keep the summation. Let's run it. So yes, it's working for the test case. Let me submit it. Yes, it is working. And here also we can get rid of one extra array and we can solve this in one array, and other array we can calculate while calculating the final result. So that's about it. See you in the next video. Thank you.